since we are done discussing about apse, perihelion and aphelion, what we will do now is we will try to solve this exercise by using all the things that we had learned. Okay, the equations that we had seen, and then also about apse and velocity. If you have to solve such a question, there is a pattern, because over here we need to find the path. Okay, and also we have to use the velocity. There is a pattern, just watch carefully what we are doing. Okay, so firstly, let us first understand the question, what it is asking us. So there is a particle, okay, and it moves on the central force. So, and it is projected from an apse at a distance a plus b. Okay, so the apse may be a maximum or a minimum distance, okay, for our convenience. Okay, let us take it to be a maximum distance. Okay, so this, okay, so what is happening over here? So if O, it is the center of force, and if A is the apse, okay, then this one will be A plus B, and the part may move in this way. Okay, but what is happening here, A will be the maximum distance. Okay, maybe it is moving in an orbit like this. A will be the maximum distance, that is OA will be the maximum, and it is projected from this point with a velocity equal to root mu by A plus B. Okay, root mu by A plus B. So we have to take note what we are discussing in this picture as well. You will see. Okay, but like I said, there is a pattern. So firstly, we will have to use equation 1 below. If you use equation 1, you see that it is F. Okay, but keep in mind that when we were deriving, F was not the force. It is in fact the acceleration. But over here you are given the force. So if you need the acceleration, mass times acceleration, so it will be only this one. Okay, again I will write it like this. So h squared u squared d2u d theta squared plus u, it is equal to the acceleration, okay, as given. Okay, this is by using equation 1. Okay, mu 3a u power 4 minus 2 a square minus b square u power 5. Okay, so this is what is happening. Next, what we will do is we will u. Okay, this one is mu, this one is u. Okay, we can divide the whole thing by u. Okay, so we will be getting okay, if we divide by u, this one will be mu. So over here will be 3a u square divided by u square minus 2a square minus b square u power 5 divided by u square will give you u power 3. So this is what is happening. Next, what do we need to do? It is best that we eliminate this h from the very beginning. And remember that h, it is a constant throughout the path. Okay, and if you remember, h is equal to pv, right? H is equal to pv by using formula number 4. Okay, but since it is constant, we can even use the formula for the apse. Okay, so h p, remember that for an apse, p is equal to the radius, so it will be a plus b, and v, it will be root mu by a plus b. So h will in fact be root mu. Okay, keep this in mind. So h square, it will be mu square, it will be mu d2 theta d2u d theta square plus u equal mu 3a u square minus 2 a square minus b square u cube. So this is what is happening. So we can cancel mu and mu. We will be left with this. Now comes a very important step. Okay, that is, remember that we had discussed before, we need to multiply now with d 2 du d theta. Okay, so we will multiply both sides by 2 du d theta, and this one will be d2u d theta square plus u, and over here, okay, it remains as it is. Let's see, 3a u square minus 2a square minus b square u cube, and then we will be having 2 du d theta. Multiply both sides by this. But also we had discussed before that once you multiply by 2 du d theta, this left hand side will change into d theta of du d theta whole thing square plus u square. And this one, okay, we can simply multiply them. 2 into 3 will give you 6. 6a u square minus 4 a square minus b square u cube. So this is what is happening, and then you will still be having du d theta. Okay, d theta and d theta, we can think of it as cancellation, can cancel from both sides. Next, what we will do, we will integrate. Okay, we can integrate it like this. Okay, so if we integrate this one, remember that we are having only d, so this one will be du d theta whole thing square plus u square, and this one you integrate with respect to u, and you will be having 6a u cube by 3 minus 4a square minus b square u power 4 divided by 4 plus a constant of integration c. So this is what we will be having. 4 and 4 will get cancelled, and over here we'll be having 2. So ultimately you will be having this 2a u cube minus a square minus b square u4 plus c. So now that we had calculated, and also for those of you who don't know how from here we got to this line, remember that integration dx, it is x, integration dz, it is z. So even if you replace z by this, okay, d, okay, integration dxy, it will be xy. So even if you replace d with something, okay, and then integrate, you will just have this one. So this is what we are having. So from here we can no longer proceed. What we will do is in fact use the condition at the apse. Okay, so after getting this line, we need to find the constant of integration. To find the constant of integration, we will have to use this. At the apse a, du d theta, it will be equal to 0. R, remember that it is a plus b, because the position of the apse was at a distance a plus b. So u will be the reciprocal of r, which is 1 by a plus b. And also we can note down that the velocity, if we do require it, and the velocity v, it's equal to how much? Root mu by a plus b. This was what we had. Okay, so now we can substitute it here. Okay, so if we substitute it there, okay, just name this one as equation 2. Okay, equation 1 was the very first equation. I forgot to write it down. So substitute it over here, you'll be getting 0. U square will be 1 by a plus b whole thing square equal to 2a. U cube, it will be by a plus b whole thing cube minus a square minus b square, and u4, it will be divided by a plus b power 4 plus c. So this is what we are having. Next, okay, again we still need to find c, so we'll take c to one side, everything else to the other side. So it will be minus 2a by a plus b whole thing cube, and over here this one will change into a plus And a square minus b square, you can easily write it down as a plus b, a minus b, and over here you will be having a plus b power 4. So a plus b, and this one will change into cube, so that will be the next line, but I'm writing it. Okay, we no longer need this stuff. So we will take a plus b cube in the denominator. This one will be a plus b minus 2a, okay, plus a minus b. So this is what we are having, and if you notice that it will become 0. So substitute in 2, substitute in equation 2, and C you will get it as 0. So this is what we are having, we are left with. Okay, now that we have got this one, but remember that we want to find the part. Okay, the part is given by r equal a plus b cos theta, if you remember. So we have to change everything into r again. How we will do that? Okay, now we will use u equal 1 by r. Okay, let us use u equal 1 by r over here, and you will actually be getting, I'll keep it to the side, du d theta will be minus 1 by r squared dr d theta. Okay, so if you differentiate, you will be getting this. So du d theta whole thing square, it will be 1 by r4 dr d theta whole thing square plus u square, which is 1 by r square, and over here we'll be getting 2a by r cube, a square minus b square by r4. So this is what we are having. Next, okay, we just need to simplify it a bit. We will keep only dr d theta on one side, okay, as you will see why. Okay, so the rest transfer it to that side. Okay, first we can even multiply by r power 4. Okay, multiply by r power 4 throughout. You will be having dr d theta whole thing square plus r squared, and over here you will be getting 2ar, and over here you will be getting minus a square minus b square. So this is what we will be getting, dr d theta whole thing square. You will be getting minus r squared plus 2ar minus a square minus b square. Okay, so that is what we are getting. And if you simplify, okay, maybe I will even write this one as minus a square plus b square. Okay, so now what we will do, we can write this one as dr d theta whole thing square, which is equal to b square. Okay, b square, I'll write it in front, and this one you can write it like this, minus r minus a whole thing square. Okay, this one, if you notice, it is r minus a whole thing square. So dr d theta, it will be root over plus or minus b square minus r minus a whole thing square. Okay, over here we have a choice whether we take plus or minus. Okay, but just think carefully, what should we take? Okay, I will take the minus sign. Just think for a bit why we are taking a minus sign. So this is what we are having, equal d theta. Okay, if we take minus sign, negative sign is taken. Okay, what happens if we take positive? Okay, that you need to think. So once we have this, now all that is left to do is integrate. Okay, we can integrate it, and this one will actually be cos inverse r minus a upon b equal theta plus c1. Okay, if we integrate, we will be getting another constant. Okay, for those of you who don't remember what the formula for this, Okay, just note that integration dx by minus 1 minus x squared. Okay, this behaves in a similar way. Okay, so this one, it is cos inverse x. Okay, but because we are having b squared over here, okay, so we will have to divide it by b. Okay, that is how it works. Okay, if you need to remember it. Also, we can do some substitution. Okay, but that will take too long. So it's best if you can do integration directly as well. And over here, we need to find C1. So what is happening over here? We were taking the initial line to be OA. Okay. So at the point A, theta will be 0. Okay. Because if it is at another point, it will be theta. But since the particle, it starts from A, so at the point A, theta will be 0. Okay. So I hope that is clear. If OA is the initial line, then at the apse A, theta will be equal to 0, and R, it will be equal to A plus B. Okay, so that is what we are having. So substitute it again in that equation. You will be having cos inverse A plus B minus A upon B equal theta plus C1. Theta will be 0. So it will be cos inverse 1, which is 0. So C1 will again be 0. Therefore, cos inverse R minus A upon B equal theta. Hence, R minus A upon B equal cos theta. Therefore, R equal A plus B cos theta. Okay, so this is the final answer that we want to get. Again, you need to remember what we did. Firstly, we use equation 1. Okay. Next, we find h by using that h is constant, and we only calculate it at the apse because h is constant throughout. Next, okay, we did some integration. We multiply by 2 du d theta. Okay, then we find the constants, and then again change it back to r. Use the limits again at the apse. Okay, by taking the OA as the initial line, and then we achieve the result. Until next time.